Oops. I want to replace age restriction. Which is used in algorithm.cxx. Only. Well, .h for the initialization in the algorithm class is a member of the algorithm apparently. Okay. Now in terms of removing it, it's not really interesting, or it is assigned, of course, or declared, or assigned, or printed, or assigned, or printed. But it is interesting to know where it is being used. And assign again, printed again. This is the real usage, I would say, whether I pass it to find extreme. In a comment, assigned, printed, another usage which is again different. We'll have 2 expected usages and 2 unexpected usages. So let's have a look at this one. Might be a typo, like age restriction is already set here to be age direction, so they are equal. Maybe, what does the neighbor use here? No, it just uses any horizontal direction. I think this just should have been age direction. But they are the same anyway. Okay, that was one. And then there's a step in that direction. To be honest, I think we should never get here. I think that if age direction is undecided, there is no way that age restriction is already being set. Okay, so this After finding a local extreme, yeah, whatever, this is in handle local extremes, fitting a fourth 3 polynomial. And then if that polynomial does not have any zeros, which is, maybe I should rename this because at least in the debug code. It's not zeros, it's zero of the derivative, so I should call it extremes. So that does not have any other extremes. Okay, let me fix this. In the I've been running into this too often now. 0, holy moly. Let's look for a 0 as part of a comment. I have to call it local as well to be precise. Okay. Yeah, the algorithm string I could leave at 0, so just keep. And then they refer to the 0 of the derivative period. Mohammed, hey. I've got what I was doing. I was looking here the uses of age restriction here. So the idea is now that probably age restriction is all. Wait a minute, is never set if age direction is not set. Age direction is like the direction that we are looking for the next local extreme relative to the previous local extreme. And then age restriction is basically a restriction on jumping to a local extreme of an approximation in order to enforce going in the right direction, which might be opposite of age direction. However, if age direction is not set, that means that We don't care which way we will find the next extreme, because we didn't find any yet. Or we did jump a long way somewhere, and there's a gap between, there's a possible gap between where we are now and where we were before, so we might go left and right, both locally unexplored territory. So, age restriction should be none at this point. And yet I'm simply passing it here. I think that should assert. So scale step, and then passing 0, what happens? Oh. Then this happens. In other words, it doesn't really matter which way we go, but we have to make a decision. And this seems to be a logical decision. Definitely fixes the edge case where we are approaching from one side. Let's say we just have samples here and there and there and there, and then you need to make a decision which way to go. Well, you don't want to go that way. You just want to go the same way that you were going before. That's what this is doing. At any rate, I think this is using age direction. I might as well use that then directly, because I'm pretty sure that if this is 0, then this is 0 as well. So just doing this is the same thing. Although I'm losing an algorithm string then. But yeah. Yeah, I'm going to delete it. How was it described? Right. Now the only usage left, apart from assigning and printing, is these two lines here. That is passing it to find extreme. I think that it's a member function of the approximation pointer. I think I should add the limits within which we want to find this extreme. Make those limits a part of the approximation object, which means that you don't have to pass anything here, because yeah, then we are inside the object that already has those limits. It does make a difference though, because now age restriction is an element of algorithm, class algorithm, and then I'm kind of moving the data from one object to another. It's a song from Spotify. I'm just counting on that they don't do any copyright checks on nature sounds, basically. So. And apparently they don't. Let's see, it's called yeah, it's just called Nature Sounds. Nature Science by Nature Science album, Everything in Nature. So if you search for that in calm seaside morning with birds or something like that. If you search that on Spotify, you should find it. Okay, what was I doing? So I have to make the decision if it is a good decision to move this information about basically the range where I'm willing to jump to. When let me give an example. Example as in so this is my current graph. This is the global minimum that we want to find. And well, that it totally goes wrong in the end when we are here. I have already explored everything on this side. We found all minima and maxima, and then I get here, and this is just a parabola. Looks like a parabola. If you just look at two samples on this thing, then you think that it is a parabola. And the parabola has a minimum around here, so deep, and then this is the minimum. And I don't want to jump to that minimum then, because then I would just jump past all the cases that I already found. It's of course completely ridiculous to jump into the middle of what I already explored. Explore, explore, explore. Yep, so that's actually 70. I thought it was larger. So in 70 steps we find this global minimum. And then the problem was that now it does not want to explore to the right, because we already found this one, and this one is supposed to be the minimum immediately following this maximum. So we definitely only want to restrict ourselves to everything to the left of this point. Yeah, everything to the right is now forbidden area. So we can and should never jump to past the 0.70 in that direction. I only still have to explore into the left direction, which does not have a maximum anymore, and we are just now going up, up, up. And that is done by making steps until we go over this energy value here, and then it says, okay, we're done, and then it returns 70 as the deepest point. What goes wrong is that in order to make this work, I had to reset age restriction, I mean, to none every time I jump to the local extreme of the fourth degree polynomial that I fit at the moment I find the local extreme. So we found this point, we fit a fourth degree polynomial, that's this green line here, which has a maximum here, it seems. I think it looks like up and then down and then through 70 and then up again. And then, yeah, it also goes up here, but it's ignorable. So we're going to jump to this point here. Yep. And then from now on, we just want to go uphill, right? But at the moment it gets here, it's no longer seeing the sigmoid. The sigmoid starts basically here and ends there or something. That's the point that we sharply changed from this parabola to the dampened sine wave. At that point it just thinks, okay, the approximation is a parabola, and it has a minimum over here. And age restriction was set to none, because I made that jump. And then we crash. Actually, it happens earlier. The sigmoid here is still influencing the parabola. So it's more straight. It's more straight line, straighter than this thing. I mean, even this magenta line that you see is already a cubic. And as you can see, it is more straight. So it has actually it has a minimum somewhere at around 775. So it's going to jump extremely far to the right, and that's the reason that it crashes, because then my formula is not calculatable anymore. But the whole bug here is, of course, that we jump past 0.70 at all. Yeah, okay, well, I guess everyone left by now, but let's make it crash. You see it go up here, and up, and up, and the next jump is to 775. So this part from 75 to 76 is already looks like very, very much. Oh, that's the reason. Yeah. No, sorry. Now it does think it's a parabola, but I'm fitting a cubic. So we're getting a cubic. We are looking. No, sorry. Yeah, I was mistaken. We are looking for a maximum, right? This is a minimum, so we're looking for a maximum on the left. Yeah. But I set the restriction to none. And this cubic here is thus a parabola that looks like it has a minimum around here. Let me draw it like that. So minimum here, and then eventually is going to have a maximum, and that maximum is at 775. And then we crash. And the reason is that I can't calculate these values for the function. This is just a function value and the derivative of that function. So another question was, does the window within which we have to move belong to the approximation object? That is the cubic. Well, it is a theoretically not answerable question because I'm not sure actually. Let me have a look. Algorithm. So currently H direction is part of algorithm. H restriction, I mean. It's highlighted. So here, this is H restriction. And that's an element of algorithm. No, okay, I was wrong. This object has a pointer to the approximation, not approximation. It's I was not wrong. Yeah, it also has the approximation object, and sometimes it points to a copy of the approximation, which is stored in the local extreme. So at the moment I find a local extreme, then I make a copy of the approximation, which is then afterwards not longer changed, but sometimes you want to linger on it, still update the scale of it. But that's actually only when we cannot jump to anything. So when there is no reasonable minimum or maximum, we just have to keep going in a certain direction in the hope to find something new. Or, well, we'll just pass the maximum energy. At that point, approximation is pointing to the approximation, or this pointer is pointing to the approximation object that is part of the local extreme, so that we can update the scale while doing that. But as soon as I am really starting to see a local extreme that we can possibly jump to in the approximation, then we switch this pointer back to this object here. Actually, it matters, right? I mean, well, okay, forget the local extreme for the moment. Then the approximation is part of this object as well. So then my question is changed from shall I move this variable into that object? And if I do so, then, well, it's still really part of this object. It's still part of algorithm. It's just now moved into approximation. So there is, I could do either way because it doesn't really matter. In terms of instances, we have the same number of instances. And in terms of ownership, we have the same ownership. Still the algorithm object that owns it, even though it's now through an approximation. Through the current approximation. The only real difference is then the fact that there is an approximation in local extreme as well. But yeah, really, that is, like I said, then the only thing I'm interested in then is increasing the scale. And that is only because that scale is being used when we don't know what to do. Otherwise, then just keep going. So I add the scale. The scale is the size over which we saw that approximation is good. And if that scale is increased, then I want to make larger steps. So we make steps away from, let's say in the previous case, we had a parabola here, and the parabola has no maximum on the left. But we're looking for a maximum. So we just make a step because there's no maximum to jump to. So we just make a step and then it still fits. So the scale is increased. So we make a larger step and a larger step. I just keep doubling that step until the energy becomes too big. My email. Why? I have a link to Discord in the description of the video. But I'm very bad with personal messages. So you can, I don't know what you want to talk about. This is Deja Vu 16. I'm doubting now. I thought it was 16, right? Yeah, 16. Well, Deja Vu some mono. Normally I use Hack. It's also a font name, Hack. H-A-C-K. But then at a smaller size. Those that looks almost the same, but this is Hack 12 point. Okay, so while I'm not seeing any extremes at all, and we just keep going by adding the scale, then my pointer is pointing to the local extreme approximation. And since there are no extremes to begin with, I think, well, actually it's no extremes that I am allowed to jump to. There's no way the H direction changes. I am not seeing the big picture. I'm also not seeing a reason not to move it though. it seems that if for some reason I would update the interval that I'm allowed to jump to of an approximation inside a local extreme, and then say the next sample disconnects from that approximation, so I switch back to this one again, then the interval that I'm allowed to jump to does not change. Which makes me feel that I then have to make a copy of that interval from the previous approximation to the current approximation. And then it can be part of the approximation. That would be kind of stupid though. Maybe I should not move it to the approximation. So I just keep it here. Which then means that I have to pass that to the find extreme member of the approximation. But that's okay. Okay, the decision is that I'm not going to move it, so I'll keep it in this object. And then I want to replace a restriction with two limits instead of just one. This is now currently using the two samples that the approximation is made up of. Which only works you know what, it should even still work in this very case that it is failing now, which is annoying. It's just easier to think about using two limits instead of this age restriction thing. Now I'm thinking about when I need two limits. Can I not just do with one limit? I mean, for example, in this case, to the last local extremity found. Let's go one further. Can I do that? It's a bit small here. Oh yeah, that was not nice either. Did there. Okay, this one maybe. The last maximum that we found was 35. And the h direction is to the left. Therefore, we want to find the minimum on the left and well, the next one, which is this one. And then, but what happens is that we start with jumping to 40 because it seemed promising, and then we discover that we have to go back because we jumped over it. And if that is flawless, then we now know that the minimum that we look for must be between 40 and 35, which is correct. It's even another minimum here. So I do never want to jump to the right of 35, but I also never want to jump anymore to the left of 40. So now we have two two limits, so a range within where it should be. And yeah, from reason that works now, but it doesn't have to. I mean, I can just make this graph do anything I want, of course. And I could make it such that the next jump, let's say we jump here, 41. If we can edit this point here locally, just move it up and down, and I can change the derivative. Then I can make this cubic be such that it has a minimum, I think. Well, actually not in this case. It should have been a bit lower. Let's say we jump to here. Then I can get a minimum on the left of the 40 if I want to. Not sure what to do then. I think I would just ignore that minimum then. Ignore it. Which would mean that we don't jump there. We insist that there must be a minimum between 40 and 35. And I would just keep going in the same direction. Yeah, I can't really think about it until I really have an example that does it, has that behavior, which would be a lot of crafting. The only thing you can say for 100% sure is that it should not jump past 35. And that's simply because I want to look for the next minimum on the left of 35. So it makes absolutely no sense to explore here again. 0. But it is not necessarily the case that maybe, yeah, I don't know. Actually, it is. I cannot jump past 40 because the derivative is like this. there is no way that the first minimum past 35 on the left is on this side of 40. Because the derivative goes down here. And here the derivative is up. Just before that, of course, because it's a maximum. Therefore, there must be a minimum in between 40 and 35. But I did not really look at it at the derivative here. I just said that there was a minimum between these points, which is possible also if the derivative is positive, like in the case of 41. Positive derivative here, positive derivative here. Yet I'm predicting that there is a minimum, namely there. Now, it would theoretically be possible that that minimum does not exist. If 41 is lower than 35, which it isn't. Then we can pick the derivative in 41 such that it predicts a minimum in between. But in reality, we could just make a sharp turn and then monotonically rise up and then here match the derivative of 35 again. So a monotonic function between this and this with a derivative such that the cubic predicts a minimum in between. So it is possible that it predicts something in between while the next minimum is on the left of 41. So then, how would I find that? Well, if you build in a limit that we can never jump past that point, then we have a problem. So I should not do that, I think. And then we get pretty close to the current age restriction solution. See, I should draw more arrows in it. It's a bit unclear what now all the state information is. Maybe I should spend some time to draw everything I know about the current state of the algorithm up here, including age direction and age restriction. And I'm getting more and more the wish that I could zoom in, I must say. Would it be nice if I just could draw a rectangle here with my mouse and then get to see that? starting to doubt. Maybe the whole age restriction thing isn't that bad. Okay, I think age restriction should always push us away from the last found local extreme, which means age restriction should always be equal to age direction. Shouldn't it be? But it isn't, because sometimes I want to go to the other side. Why? If somehow I would end up with 2 samples on this flank here, like here and there. I'm not sure that is possible, but everything is possible. Yeah, then I want to go to the right, of course, in order to find this point here. So in that case, I would jump to the minimum on the right. Left would not work there as an age restriction. Unless I replace age restriction with a border that sits on 35. Okay, so why exactly went it wrong? If I don't reset H direction, maybe this will give insight. So I don't reset the H section here. We will not get as far as we did now. And I think it might give insight to see that. Oh, right. Yeah. Okay, we missed this minimum here. Let's zoom in a little bit. Although maybe it's 26 important, maybe. It's not much to zoom into then. Okay, let me go from minus 55. So let's say minus 55 to, start even now, well, I don't know, minus 10. And then draw up till 2400. That automatically works. Just minus 55 to minus 10. Yeah, that was already wrong. So ignore this minimum because I guess we said that, well, I want to be left of 23. Could zoom in on that. Let's do from minus 30 then. It's the very first case where it happens. So yeah, find the local extreme. Now we want to find this point, and we begin to jump into 23. This gives me a straight line at the moment, which is I'm gonna change all that, but well, the more bugs we find, the better. So a straight line just keeps going, and we randomly pick 24. Now maybe that is the reason, because yeah, it's kind of random. This was already a bug basically, what I left in on purpose. Nevertheless, now we have 23 and 24. I just want to go to the right, of course, to the right of both 23 and 24. We want to go to this minimum. But if I leave H restriction to left, to the same direction as H direction, that means it wants to ignore anything on the right of 23. So we want to go through that way. There is no minimum in this area. Therefore, I don't know, it just continues in the same direction. But we should have jumped there. How could I have known in advance? Now this would work if I set H direction to right, the opposite of H restriction. So then we want to find anything in this area. But yeah, then I'm even, you know, possibly jumping past 22, which is just nonsense. So it seems to be actually quite nonsensical to set the restriction to going to the right. I would rather have no restriction, but that's also not true, as we saw later. I seriously do never ever want to jump past 22. So yeah, even though it's not important, it will not happen. It's still a restriction that is valid. So maybe I should replace age restriction with simply the last found local extreme, and then say we are not allowed to jump past this point to the right. So that would be a pretty fixed thing until we find the next local extreme. 23. Yeah. Why are we going to the left here? Small step. I think small step uses H direction even. Really? Wait. That was the shoot. Yeah, it's using H direction. Oh, this is bullshit. That is just bullshit. Or is it? That's pretty much bullshit. This should be more like uphill or downhill decision, not horizontal direction. How do I get the derivative? This we are in a sample, right? Handle single sample. W, I'm having a current here. I think I can use this. Let's call it V direction, vertical direction. No, I don't know. Slope direction. Just slope. It's plus or minus 1. So it's not really slope. It's more direction of the slope. Up, down. I don't like this. This is not a smiley. One of them must be next extreme type equals something. If we are looking for a minimum and we want to, this would be negative, so then we go to the left. Looking for a minimum, then we want to go left if the slope is No, might as well test it directly. I don't know, one of the two. I'm just filling it in. So rethink this. So if the next extreme is a minimum and the slope is positive, I think. Then we want to go to the left. So this should work. And it worked. So now we go to minus 19.8 instead of all the way here. Which happens to be almost exactly in the minimum. Coincidence. Seems that that now finished. Why is this not printing? I wanted to print a local global minimum. I'm editing the wrong thing. Well, we reached a point where it should find it. So might as well add this. And then I need to know what the value is. Oh, not good. It's not finding the global minimum. Fuck. Yeah, it thinks it's at minus 45 now. This one. Okay, but that's because I'm not resetting age restriction at the moment. Yeah. Maybe I should not have zoomed in then. Zoomed out. We find this point, jump there, and now we go down. That's a minor improvement. We find that point, and then for some reason, this 4th degree polynomial fit is very good. We jump here. And again, it's very good 4th degree polynomial fit. And again. And a complete failure. This is not a good 4th degree polynomial fit. Where the hell did it jump to? Minus 89. Holy moly. Yeah, that can happen. That sort of thing can happen. So now we are backtracking to this point. And now we should be backtracking to this point. And then we are going forward again till we have this minimum. So that works like a charm. This time the 4th degree polynomial is pretty good. So we end up here. And then the small step should be looking for a maximum, and the slope is like this, so we should go up with whatever small step is. Yeah, pretty big step in my eyes, but why not? It's not like it jumps all the way here. So yeah, okay. Now then we bang have this point as well. And then the 4th degree polynomial fit here is finding a minimum somewhere here, which is fine by me. And then again I have a slope. And we're looking for a minimum, so now it should go to the right, and it does. It goes to minus 57. Don't know where that is. That's here? No. Well, maybe. And then we go to minus 59 as a keep going. So the keep going is also going in the wrong direction, same as the small step. It's now going to the left, what really we should be going to the right still. And I think that the reason is that we don't have 0, so that doesn't print it. This cubic seems to have a minimum, but way to the right, where it is ignored. Yeah. The zeros only referred. Oh, we're printing something about the zeros is only happening when we just plotted or fitted the fourth 3 polynomial. This is probably is the algorithm that belongs to the normal cubic fit and then not have an extreme to jump to. And it wants to go left, so it's going left again, which is nonsense again, because clearly there must be a minimum between 54 and 56 in between here. Okay, where's keep going? Yeah, I think it's time for a break as well. What to do? Yeah. So what happens here is we do call find extreme, passing left to as age restriction. Therefore, it doesn't find the extreme, the minimum that there is a minimum like far on the right, which it ignores. Rightfully, I would say. And that means that extreme type is set to unknown because it couldn't find an extreme. There we enter this block. And then we just continue left. But that's, yeah, nonsense in this case. So the code is not correct. I think that what I should do instead is see what is the problem of going so far to the left. Sorry, right. Finds an extreme very far to the right, but it can't because we don't want to go past a certain point. That's the whole reason why the age restriction was set. At that point, I could use the local extreme. So that point, what is it, 35 at the moment. And then I think that given that situation, a good thing would be to go halfway. So not go to the found extreme, very far to the right, but more like halfway where we are now and the limit. And in order to make that decision, I need to replace age restriction with that border that we can't pass. Maybe I can set one of these results to, like, I don't know, clamped, and then return the clamp. And then we can check if the clamp is set, and then use the new W as the clamp. Yeah, I like that idea. Then I need to have a current point as well, because the current point is I'm going to take a break. Think about this. Every time I make the decision to take a break, the sun is shining, and I'm like, I want to go outside. And then by the time I actually take the break, there's clouds again. What the F? Give me a break. So now I have no other option than to play chess before I take my break until the sun shines again. Really. Hmm. So now I can win a bishop, but then I get check here. And I have to go there. It's not mate. Maybe we should take the pawn here or check. We're going mate if I leave the bishop here. Check. Go there. Check here maybe. Go there. I don't go mate. I don't think I'm going mate here. You could win a rook though. Check, I go here, it takes another pawn, and then after that my rook. But in the meantime I have two rooks or something. Bishop, take, go there. Take. Can't decide, taking here or there. Defending is not an option, really. Not gonna do that. I push this pawn and just gives check and I lose all my opportunities. I'm gonna check here, I'm gonna take a risk. Can't calculate it. Not bad. That's true, yeah, true. It's just one rook and I'm gonna lose another rook anyway then here. It's maybe I should have taken the bishop. Yeah, I can no, I cannot. Can I? Take here, I would threaten mate if the queen was not here. Could do this. No mate threat. The bishop goes here. And then I take the knight. Aha. I'm threatened to take the knight. So what is he gonna do? Take check, I take. Knight goes away, he takes my queen. But then he can go here. Well, let's see what happens. Not much options. So now I'm threatening mate in one, and I'm threatening to take a rook, and I'm threatening to take a knight. Oh, yeah, I missed that one, did I? No, not really. I'll put this one in between. But I'm no longer threatening mate. Ouch. So the rook could go here now, and then everything is defended. Yeah, this is not really good. This is not good for me. think he should take here. I take back. Oh, then he cannot give check anymore. Oh. So maybe first check, I go there and then take the knight. That would be at least a whole piece. So now this check's gone, that check is gone, all the checks are gone, except no double attack there. Should probably just take the bishop, huh? To defend this. Do I have to defend it? Not really. No time left, damn it. Okay. Okay. Losing on time also. Oh, we can still take here. Oh, I thought it blocks this, but now it takes like that anyway, of course. I have another check. Oh no, I don't have a check. I don't know, no time. Yeah, not happy. Not happy at all. Oh, no, lose on time. Fuck. Okay, break time.